Good morning, everyone. Good morning po, ma'am. Today, we are going to discuss the experiment 5 or the methods of purification of organic compounds. An organic compound resulting from a reaction usually impure, owing to the presence of small amounts of materials from which it was prepared, or to by-produce or other products formed by secondary reaction. These impurities may either be mixed with compounds or absorbed by it. So, sa mga compounds na ginagamit usually sa experiments, those compounds are not actually in pure form. Nagyapon na sila impurities within their substances. So, in order to extract or remove those impurities, we need these purifying methods that are listed on the next slides in our presentation. Therefore, it becomes necessary to eliminate the impurities. A few of the general methods used for this purpose are outlined below. The method to be used in any one case will depend upon the nature of the substance to purify and also the impurities present. So what is purification, by the way? Expound lang nato ang purification para klaro. Purification is the physical or chemical processes of removing contaminants or the impurities from a compound. The physical processes may include sublimation, distillation, filtration, crystallization, extraction, or decolorization. Sa experiment 5 nato, ang methods na gamit nato diri are sublimation, sublimation, crystallization, and decolorization. Next. The materials for this experiment are for the crystallization, we need crude oxalic acid, urea, ethyl alcohol, impure benzene or acetone, picric acid, ether, starch, iodine solution, brown sugar. And then filter paper, tripod or funnel, test tube holder, evaporating dish, watch glass, cork or cork borer, cellophane paper, mothballs or naphthalene, salt solution, and silver nitrate. Later guys, magpakita din mi og video sa procedure, pero ang mga video kay dili siya tong exact nga video sa procedure, bali ano lang siya murag same lang ang method nga gamit and ang materials, pero dili exact nga procedure nga naa sa tuang experiment 5. Next.
Procedure for crystallization. First is to 10 cubic centimeter of water in a test tube, add 5 grams of crude oxalic acid and shake. Next is to boil for 2 minutes or until all the crystals have dissolved. Lastly is to filter while hot and cool filtrate in iced water contained in a beaker. Note that do not shake while cooling.
Wala. Nani siya yung sound. Paki-share ang sound chain. Nasa taas, view options, and then share sound.
Wait lang.
पहले यूज़ करने से पहले आज का जो हमारा प्रोसीजर है उसमें हम फॉलो करेंगे। फर्स्ट हम 1 ग्राम ऑक्सैलिक एसिड वे कर लेंगे। जो हमारा ऑक्सैलिक एसिड हुई है 1 ग्राम, इसे हमने वे कर लिया है। सेकंड, हम 40 ml वाटर लेंगे। और 40 ml वाटर इसमें यूज़ करेंगे इसको डिज़ोल्व करने के लिए। नेक्स्ट हम क्या करेंगे, 40 ml वाटर को बीकर में ले लेंगे और 1 ग्राम ऑक्सैलिक एसिड इसमें ऐड कर देंगे। फिर उसे हम ग्लास रॉड से डिज़ोल्व करेंगे। नेक्स्ट स्टेप, हम इसे हॉट प्लेट पे रखेंगे कि हमारा जो इसका वॉल्यूम है 40 ml से 20 ml हो जाए। उसके बाद हम इसे आइस बाथ में रखेंगे। नेक्स्ट हमने इसे हॉट प्लेट पे रख दिया है। अब ये वॉल्यूम रिड्यूस होगा, इसकी वॉल्यूम को हमें हाफ करना है। ये 40 ml हमने लिया था, ये 20 ml हो जाएगा। नेक्स्ट देन ये हमारा वॉल्यूम रिड्यूस हो चुका है 20 ml। ये हमने वॉल्यूम को रिड्यूस कर लिया है हॉट प्लेट से रख के, और हमने हीट दिया था और ये अब रूम टेम्परेचर पे भी आ चुका है। अब इसे हम आइस बाथ पे रखेंगे जिससे ये कूल हो सके, और कूल होने के बाद क्रिस्टल फॉर्म करे इस पर। हमने इसे आइस बाथ पे रख दिया है। अब ये कूल होगा और धीरे धीरे क्रिस्टल फॉर्म होगा इससे। और ये हमने बीकर को आइस प्लेट पे रख दिया है और एक क्रिस्टल भी फॉर्म होंगे इसमें। ये हमारे धीरे धीरे क्रिस्टल फॉर्म हो रहे हैं इसमें। धीरे धीरे हमारा क्रिस्टल इसमें फॉर्म हो रहा है। ये हमने क्रिस्टल को फिल्टर पेपर से इसे निकाला है क्रिस्टल को। ये जो हमारे बचा हुआ वाटर है इसमें, और ये हमारा क्रिस्टल है। ये हमने क्रिस्टल को निकाला है। ये हमारा क्रिस्टल फॉर्म हुआ है।
particularly problems associated with internal energy, heat, work, iso.
What is the principle involved in the method of purifying oxalic acid? It is the process of crystallization wherein the crude oxalic acid is being boiled until dissolved. After it dissolves, it crystallizes back as it cools down. The oxalic acid now has been purified and the impurities were filtered. Where are the impurities found? The insoluble impurities are left behind in the filter paper. Next procedure for crystallization is, first, in a test tube, dissolve 1 gram of urea in 10 cubic centimeter of alcohol by heating in a water bath. Next is to set aside to cool in a beaker with ice water.
Ma'am, wala gid kay sound.
Walay sound ang video.
Wala po.
Wala dyan na siya daan sound.
Wala po.
It's okay. May caption mo ka siya.
with internal energy, heat, work,
What is the principle involved in the method? The principle involved is the crystallization of the urea wherein a mixture of urea and alcohol were heated in a water bath. After it was cooled down, it crystallizes in ice water, making it now a pure form of urea without the impurities. Where are the impurities found? The impurities within urea has evaporated due to the heating of the solution, thus leaving urea formed into a pure crystal in the beaker. Last procedure for crystallization is crystallization at low temperature or in freezing temperature. Place 10 cubic centimeter cubic centimeter of temperature of benzene in test tubes it in a freeing mixture or ice bath. Last is to allow stand for a few minutes and observe the crystals formed in freezing.
Purification of benzoic acid by crystallization. Benzoic acid is a colorless crystalline solid and it is an aromatic carboxylic acid. The pure crystals of benzoic acid can be prepared from an impure sample by the process called crystallization. The crystallization process involves preparation of solution of the impure sample, filtration of the hot solution, cooling of the hot saturated solution, separation and drying of crystals. Our aim here is to prepare crystals of pure benzoic acid from an impure sample. Materials required: crude sample of benzoic acid, distilled water, cold water, 250 ml beakers, funnel, filter paper, glass rod, spatula, dropper, fluted filter paper, test tube, stand with lamp, trough, wire gauze, tripod stand, and a Bunsen burner. Procedure: preparation of solution of the impure sample. Take about 150 ml of distilled water in a beaker. Boil the water in the beaker over the Bunsen burner. In another beaker, take about 3 grams of crude sample of benzoic acid. To this, using a dropper, gradually add a minimum quantity of boiling water, just sufficient to dissolve benzoic acid. Stir using the glass rod. If required, heating can be done to dissolve benzoic acid. Filtration of the hot solution. Place a fluted filter paper in the funnel and clamp the funnel to the stand. Place a beaker under the funnel. Pour the solution into the funnel over the glass rod and collect the filtrate in the beaker. The insoluble impurities are left on the filter paper. Cooling the hot saturated solution. Let the filtrate come to room temperature by itself. Cool it by placing the beaker in the trough containing cold water. As the solution cools, white crystals of benzoic acid begin to separate. Separation and drying of crystals. Clamp the funnel in which a filter paper is fixed to the stand. Place a beaker under the funnel and separate the crystals by filtration. Wash the crystals with cold water. Place the crystals on a filter paper which soaks up the solution. Transfer the crystals to another filter paper and dry them by pressing gently between the folds of the filter paper. Now transfer the crystals into a dry test tube. The crystals of benzoic acid are opaque white. Precautions: cool the hot saturated solution without disturbing it. Remove the insoluble impurities by filtration.
So I'm going to
What is the principle involved in the method? The principle involved is the process of crystallization of benzene, wherein certain amount of benzene is frozen in a test tube. As a result, it crystallizes, making the benzene now a pure substance since the impurities are cooled. Where are the impurities found? The impurities are within the freezing mixture. However, they do not crystallize because the lower temperature caused the solubility of the impurities in the solution to decrease.
For the procedure of sublimation, A. Place 1/2 of a mousse ball, the naphthalene, inside a small evaporating dish and cover with a funnel with a cone-shaped filter paper. Then heat the evaporating dish with a small flame over wired gas. Cool without removing the funnel. The naphthalene will vaporize and sublime on the filter paper. Then observe the structure of the sublimate.
Confident messages, stronger essays, and more.
So what does the result indicate? Since the naphthalene ball was inside a covered container and was put over the flame indirectly, it caused the moth ball to sublimate, turning its cold state into a gaseous state.
Decolorization. To 1 cc of brown sugar solution in a beaker, add 3 grams of bone black or charcoal. Next, boil for 20 to 30 minutes. Filter repeatedly if necessary with the original sugar solution.
In this video, you will learn how to use decolorizing charcoal to remove colored impurities from a solution. First, heat your solution on a hot plate until it is boiling. Then, using a scoopula, add a small amount of decolorizing charcoal. Use a clamp to lift up the flask and swirl. Your solution should be homogeneously black from the added charcoal. Using the clamp, pour the solution in the center of the filter paper set up for gravity filtration. Due to rapid cooling of the solution, precipitate may form in the funnel. If this happens, add hot water to the center of the filter paper.
How was the decolorization accomplished? In order to do so, animal charcoal was added to the solution to remove the impurities of the solution. The charcoal absorbed the impurities from the brown sugar, and when it was filtered, while still hot, the brown sugar became clear like water. Differentiate absorption from adsorption. Absorption is the process in which a fluid dissolves by a liquid or a solid, or is where a liquid is soaked up into something like a sponge, cloth, or filter paper. Adsorption refers to individual molecules, atoms or ions, gathering on surfaces, and the phenomenon of adhesion of the molecules of a substance on the surface of a liquid or solid is adsorption.
So let's proceed to the schematic diagram of each procedures. So crystallization, to 10 cubic centimeter of water in a test tube, add 5 grams of crude oxalic acid and shake. Boil it, boil it for 2 minutes or until all the crystals have dissolved, and then filter while hot and cool filtrate in ice water contained in a beaker. Please do note that do not shake while cooling. Then, in a test tube, dissolve 1 gram of urea and 10 cubic centimeter of alcohol by heating in a water bath. Then set aside to cool in a beaker with ice water. Crystallization at low temperature or the freezing, place 10 cubic centimeter of temperature of benzene in a test tubes in a freezing mixture. Allow stands for a few minutes and observe the crystals formed in freezing. Next is the sublimation. Place 1/2 of a smooth ball in a small evaporating dish and cover with a funnel with a cone-shaped filter paper. Then heat the evaporating excuse me, Heat the evaporating dish with small flame over the wire gas. Cool without removing the funnel. The naphthalene will vaporize and sublime on the filter paper, and then observe the structure of the sublimate. Next is the decolorization. To 1 cubic centimeter of brown sugar solution in a beaker, add 3 grams of bone black or charcoal. Boil it for 20 to 30 minutes, and then filter it repeatedly if necessary with the original solution of sugar.
So, what is crystallization? It is used in the chemistry as purification technique for solid. It is natural process which occur as materials solidify from liquids or as they precipitate out of a liquid or gas. This change can be caused by factors such as temperature change or acidity change. Number 2, define recrystallization. Recrystallization is a laboratory technique for purifying solids. The key features of this technique is causing a solid to go into solution and then gradually allowing the dissolved solid to crystallize. It is a very challenging process to get completely right. The goal is to obtain a compound in high purity uniform crystals. Recrystallization is therefore a purification technique. Number 3, why should hot solution be filtered rapidly? A hot filtration should be used for filtering solutions that will crystallize when allowed to cool. It is therefore important that the funnel is kept hot during filtration through contact with hot solvent vapors, or crystals may prematurely form on the filler paper or in the stem of the funnel. 4. Differentiate distillation from extraction. The main difference between distillation and extraction is that the distillation includes the purification of a substance that is in liquid mixture, whereas extraction includes the purification of a substance that is either in solid phase or liquid phase. Wala ata si Emonaga.
In conclusion, this activity explained the different methods of purifying organic compounds, namely crystallization, sublimation, and decolorization. We have learned that in crystallization, if the mixture contains impurities, that have the same solubility as the compound to be purified, repeated crystallization is performed. So itong nakita na itong video gay na for crystallization, naay method dito na wait lang. Ang example atong for benzene is si benzene, according sa ko ang na research, si benzene is ang iyang solubility with the solution kay dili kay siya likely soluble sa katong gi-combine with sa iyang. So need siya i-repeat ang crystallization or katong gibawas-bawasan gud ang tubig sa iyang beaker para ma-contain ang katong benzene crystals na lang gid. Meanwhile, in sublimation, tong sa naphthalene balls, ang phase change ato from the solid phase into gas, mo to siyang indication na ang impurity sa within that compound or substance has sublimated or vaporized. In addition, sa decolorization, katong activated charcoal, the change of color of the substance being purified indicates that the impurities within it has been filtered out of the solution, therefore leaving the substance in pure form or crystal clear or clear na tong water na lang ang naging outcome after gidagdag si activated charcoal. So the activated charcoal decolorize the solution, making it pure form na po. So that's all for the experiment 5.
Okay, I kindly reshare the PPT so that we will explain natin. Okay, thank you, reporters. This is about purification of organic compounds. Class, do not expect that all of our chemicals in the laboratory are considered pure. Okay? Some of them have impurities. Merong ibang chemicals na nakasali doon sa mga powder or sa mga crystals. Now, if we want to do an experiment using a pure substance, kung benzoic acid lang talaga, wala nang ibang nakahalo, then that's the time we do the following methods for purification. So we have 3. Supposedly, we are going to conduct this in the laboratory, but video na lang muna tayo. But do not forget, we have 3 methods mentioned here. In the experiment, we have the crystallization. We can call it also recrystallization. And then the sublimation. And lastly, the decolorization. Pwede pa move doon sa... Sige pa. Doon sa iyan. So sa crystallization, so what is the principle involved in the method of purifying oxalic acid? Actually, the answer here is still crystallization. Kaya nga, nakasali siya dyan sa crystallization. Kasi if gagawin talaga natin itong purification ng oxalic acid, we will be getting the pure crystals. So, example, meron tayong crude oxalic acid. We will consider it as impure. And then, ilalagay natin siya sa test tube. Lalagyan natin siya ng water. And then, we will boil it for a certain period of time until all the crystals of the oxalic acid have dissolved. And then, after that, if we filter siya immediately while hot, and then ipapa-cool down. So while cooling, you will see there that the crystal, there will be formation of the crystals, but that crystal na mafo-form will be considered as pure. So yung mga impurities, pwede siyang naiwan doon sa filter paper. Yung iba naman is na-dissolve doon sa solution. Hindi na siya nasali when the crystallization happen. So yun yung principle natin ng crystallization or recrystallization. That is also true for the other procedures under this crystallization. So though nagbigay naman ng video yung reporters kanina, let us also have this. Wait. That's it. So nakita niyo na though ang doon talaga is deliberate, as in hindi talaga accidental yung impurities, talagang mimix talaga. Pero you can see na we can really separate the naphthalene from the sand, na makukuha mo yung pure naphthalene lang talaga, maiiwan ang sand through the process of sublimation. Okay, questions about the sublimation, class?
None na, ma'am.
Okay. Sige. Now, yung sa naman, sa decolorization, ang example natin dito is brown sugar, which is pinakita naman na ng mga reporters yung video. Pag ang brown sugar, nilagyan mo yan ng charcoal and then i-boil mo for some minute and then mag-filter ka, makikita mo, class, na nawala na yung color ng sugar. So, yun yung process ha. That's how you accomplish the decolorization. And the principle behind that is the adsorption process. Kaya may question dyan sa worksheet ninyo, ano daw yung difference ni absorption and absorption? Si absorption, class, kagaya na ito ng sponge. If meron kang sponge dyan, di ba pag nilagay mo siya, example sa baso, i-absorb niya yung For example, water. So papasok talaga yung water sa surface ng sponge. That's absorption. As in, the particles, the molecules, the chemical substance will really go inside the material. But if it is adsorption class, take note, AB ha, adsorption, the material will just stick out to the stick to the surface of the adsorbing material. So in this case, charcoal is actually our adsorbing material. Kaya nga 'di ba may napansin kayo na minsan ang ref nilalagyan ng uling, or kung may tinatrabaho sila sa bahay and then nangangamoy, naglalagay sila ng uling, like nagpipintura, tapos after painting, naglalagay sa room ng uling. That's actually the process of adsorption, kasi capable talaga ang charcoal of doing that. Example, this is a piece of charcoal here. Kapag may mga particles dyan, especially gas particles class, kaya niya yang stick dito sa surface niya lang. Hindi talaga siya papasok class ha sa inside sa charcoal, unlike the absorption na talagang papasok inside the absorbing material. Si charcoal hanggang dito lang siya sa surface, but nevertheless kaya niya yung kunin. So kung example, the impurity can cause color to the original substance, then we can get the color by sticking the impurity doon sa surface ni charcoal. If kung sa ref naman yung pag-uusapan natin, pag may nangamoy na nilagay sa ref, then yung mga particles ng gas na nag-cause ng odor, magsistick din yan siya dito sa surface ni charcoal. Yan yung adsorption process class. I hope you can differentiate now what is absorption and what is adsorption. So for the decolorization process, it's called adsorption. Okay? Questions about the decolorization process? Dapat ang gagamitin dito, ano talaga ha, adsorbing material. So na-define na natin yung crystallization and recrystallization kanina. These are method of purification wherein we will subject either to heating or freezing yung material natin to get the pure crystals. And then I have answered this question also a while ago. Why should hot solution be filtered rapidly? Because as the temperature goes down, babalik siya sa room temperature niya, mag-crystallize na yung substance natin. At pag hindi natin siya finilter agad, masasama yung crystals doon sa filter paper together with the impurity. So dapat after heating, filter agad so that impurities lang yung maiiwan sa filter paper, and then mainit pa yung solution mo, hindi siya mag-crystallize agad. After na siya sa filtration, mag-crystallize. So nahiwalay natin yung impurities and the crystals. Now, how about distillation from extraction? So parati ito, by the way, ginagawa sa laboratory. Both of them, distillation and extraction. Si distillation, ginagamit natin as method of separating mixture. Again, si distillation ay ginagawa natin to separate components of mixtures. Example, nagmix ka ng alcohol and ng water, which is, by the way, very common. Yung ginagamit natin na disinfectant ngayon, like 70% alcohol, hindi siya pure alcohol. Meron siyang tubig na laman. So if we want to separate that, we can do distillation. So yung distillation setup, na I think na-present ko yan during the activity number 1. Example, you have the flask here. Lagay mo dito yung solution ni alcohol plus ni water. I-subject mo siya for heating here. Subject mo siya sa heating here. And then after heating, mag-e-evaporate kasi yan. So kung sino yung una mag-evaporate, yan yung una mong ma-separate. So mag-e-evaporate siya as gas. So ang gas, papasok yan siya dito sa, we call this condenser. So dito, ang temperature niyan ay low. So dalawang process yung sa yung sa distillation ha. The first one is evaporation and then the second one is condensation. So ang liquid magiging gas, pero ang gas pagdating sa condenser magiging liquid siya ulit. So makukuha mo siya dito sa receiving flask as liquid. So kung sino yung unang nag-evaporate, yan yung mauunang separate mo. That's distillation. So mag-expect tayo among the two, syempre si alcohol talaga unang mag-evaporate. So mag-expect tayo na ang unang tutulo dito na liquid is alcohol. Ang maiiwan dito sa flask is water. That's distillation. But when you say extraction, this is more of solid and liquid. Mostly sa extraction na ginagamit natin sa laboratory is mostly sa plants. Especially if we want to get the phytochemicals, the chemicals in the plant na gusto nating makuha kasi meron silang activity, for example, as a drug. Okay? Diba? Yung ginagawa nila, example, ano ba yung mostly iniinom ngayon na herbal preparation. Example, ampalaya for diabetes. So meron yan kasing chemical substance si ampalaya class that can lower the blood sugar. So kung gusto natin kunin yung chemical from the ampalaya, we do extraction. Anong ginagawa sa kanya? Yung ampalaya, nilalagay siya sa solvent. So solid na ampalaya, ilalagay mo siya dito sa solvent. And then pababayaan mo lang siya after some time, pero syempre dapat may takip yan para hindi mag-evaporate yung solvent mo. And then dapat ang solvent na gagamitin dito is suitable na nakaka-dissolve talaga siya, no chemical na nasa ampalaya. Okay, so for example, the chemical na nasa ampalaya is soluble sa alcohol. So alcohol yung ilalagay natin for extraction. So magkaiba sila ni distillation. So isasubmerge mo lang ito for some time yung ampalaya dyan, and mag-expect ka na na-dissolve na nakuha from the ampalaya mismo, makukuha ni solvent yung mga phytochemicals. Now after that, mag-filter tayo. This is the process of extraction. I-filter natin. Bakit tayo mag-filter? Kasi syempre ihihiwalay natin yung solid na ampalaya and yung solvent. And then yung solvent ngayon, andito na yung mga chemicals from the ampalaya. Okay? So pag nakuha mo na yung ampalaya through filtration, tatapon mo na yan, ito na lang yung kailangan mo. And mag-undergo pa ito ng series of extraction process para ang next na naman na step is to get rid of the solvent. Mostly meron tayong pwede natin siyang i-subject to distillation. Ilagay natin yung solvent dito na may phytochem. Tapos, ang gagawin kasi, mag-i-evaporate yung solvent. Mag-expect kasi tayo na mostly like alcohol, madali siya mag-evaporate. So, pag evaporate niyan, makukuha mo yung alcohol. Ang maiiwan dito sa flask, yung phytochem na. So, that's how we do the extraction in the laboratory. So, kadugtong pa rin ni extraction si distillation. See, distillation is through the use of solvent. You can get materials or you can get chemicals from your materials like the plant materials. So yun yung difference nila. Do you have questions, class? Alin dyan yung hindi naintindihan? Okay, usap mo natin explain. Ano ba? Wala? Wala, panguta na? Sure na? Sure na ginaha. Sabak na yun.